Okay, so this is section 4.3, and this section is actually divided into two parts. Not because it's not super long, but it kind of helps to divide it up a little bit into two parts because the part we're going to look at in this video is really just concerned with graphs. And then for part two, we're going to be looking at equations or functions more than the graphs. And so it kind of helps to break it up, I think. And this also can be a bit tricky. So I remember when I took calculus, this part on the graphs specifically um, probably gave me the most trouble of anything in the course. So, but I'll try to explain this as detailed as I can and show you kind of the tricks to help you remember the important things and how you can kind of navigate your way through this. So the first thing we have is called the increasing decreasing test. And you probably already know this. You should know this. If f prime is positive on an interval and f is increasing on the interval, and that should make sense because f prime, the derivative, is just talking about the slope. So if the slope is positive, the graph is increasing. That, of course, makes sense. And then if the slope is decreasing or f prime is negative, sorry, the slope is negative or f prime is negative, then the graph is decreasing. So hopefully you know that. That should be fairly obvious. Now, if we look at the first derivative test, so if c is a critical number, and you remember from um, a section or two ago, we talked about critical numbers, and that's just anywhere that the derivative equals zero. That's any x value, either where the derivative equals zero or the derivative does not exist. So if f prime changes from positive to negative at c, then f has a local maximum. So we'll draw pictures of these as we go. So for this first one, if f prime, so this will be the graph of f. So if f prime is positive, the graph is increasing. F prime changes to negative, the graph is decreasing. So there would be the critical number, and we have a maximum. And similarly, if the derivative goes from negative to positive, so negative means we're decreasing, changes positive, now we're increasing, we are going to have a minimum at that point. And if it does not change signs at C, so it is possible to have a critical point where you're not changing from positive to negative. You're staying the same. And so an example of this would be x cubed, f equals x cubed. So at zero, you do have a critical point. The graph does flatten out there, so the slope would be zero at that point, but it's not changing from increasing to decreasing. And if you look at the derivative of x cubed is 3x squared, and that is always positive, so which makes sense because x cubed is always increasing, so the derivative should always be positive. But we do have this one point where it is zero. So I guess maybe we should say it's non-negative the whole time. So it's positive everywhere except at zero. So just because you have a critical point doesn't mean you're going to have a max or a min. You could have neither if the derivative does not change signs. All right, so then we're going to talk about concavity. So we have, oops, too far. So a function or its graph is called concave up on an interval if f prime is increasing on that interval. So now we're talking about the derivative increasing. It is called concave down if f prime is decreasing. So it's very important that in this homework that you pay attention to if we're talking about derivative or the function, and then we'll also later talk about what the second derivative is doing. So we have different examples of concavity. And so if we look at that one, that is concave up, and this function is increasing. And so what's going on here is if we look at the tangent lines down here, these tangent lines are, it's increasing the whole way. The tangent lines, though, have a very small slope. So the slope on around here would be close to zero. It'd be positive, but close to zero because we're getting kind of flat. So let's just say 0.5, 0.6, maybe, well, not one, probably wouldn't be one, but let's say 0.2, 0.3 is the slope, 0.5 maybe. Then as we get up here and we look at the tangent line, now we're getting a steeper slope. And so now the slope is going to be 3, 4, 5. So instead of 0.2, it's going to be 0.5. So the slope is increasing. The function is increasing and the slope is also increasing. And so when the slope is increasing, the derivative is increasing, that means we're concave up. Another way to look at this, we could see down and decreasing. So concave down and decreasing. And so kind of the similar thing is going on here, or at least we can look at the same thing. Here, we're decreasing the whole way, but here the slope is a small negative number. So negative 0.2, negative 0.5, whatever it is. And then as we move down here, the slope is going to be a bigger negative number. So negative 2, negative 3, negative 5, whatever that is. So we go from negative 0.2 to negative 2 or negative 3 or whatever that slope is. So it's decreasing and the slope is also decreasing. The slope is going from negative 0.2 down to negative 2 or negative 3 or negative 5, whatever it is. So the slope is going down. F prime is decreasing, so we are concave down. Now we could also mix these up in other ways. So we could have like this. So that is concave up, but it's not increasing, that is decreasing. The function is decreasing. So I guess just so we're clear, F, we're talking about F on this. So F is concave down, F is decreasing. F is concave up, F is decreasing, but the F prime, the slope is increasing because, or sorry, the slope is increasing. So here the tangent line slope would be a larger negative number, negative 5, negative 8, whatever it might be. And then here we're getting closer to 0. So it's going from negative 5 to 0, it looks like, if we kept going. So the slope is going up. The slope is increasing, so that's why we're concave up. And I know you can see from the picture, but you're going to have to be able to look at the numbers sometimes and not just the graph, or vice versa. So we need to be able to see this relationship. And then lastly, we have this one, which is concave down and increasing. I'm still talking about F. And I'll let you work that one out. But those are the 4 possibilities for concavity. All right, so then we can talk about inflection points. And so a point on a curve is called an inflection point if F is continuous there and the curve changes from concave up to concave down or vice versa at that point. So we'll draw kind of just a sketch here. And inflection points are easy to find if you have the function, but to see them on the graph, and of course, my graph is not great, but at some point here, and when you have a computer drawn graph, it's easier to tell, but usually about halfway between the min and the max or vice versa, you can see where it kind of goes from concave down to concave up in that case, or vice versa in that case. So these would be the inflection points. Now, if we go down, oops. Let's just kind of sketch down. Here we are concave up, and then between these 2 inflection points, we are concave down, and then after that, we are concave up again. Okay, but again, when you see, and we have a computer drawing here, so we can look at that. But wherever it changes from concave up, concave down, is usually about halfway between the max and the min. Although it doesn't have to be. Like it could really drop off here, and then it starts changing again soon. But you get the idea, and you'll be able to see once we get on this one. All right, so this is the graph of f prime. And so we're going to answer a couple of questions, and it's important to remember. So think about the first couple of things that we saw on the first page. So where is f increasing or decreasing? So f is increasing when f prime is positive. F is decreasing when f prime is negative. So this is f prime. So where is f prime positive? So f prime is positive from 10 to 45. So we have 10 to 45. This will be increasing. And then it's positive again. That would be 40, 50, 60, 60 to infinity. And then it's going to be decreasing everywhere else. Or we could just say, where is it negative? So negative infinity up to 10. Union, and then it's also decreasing, or yeah, negative, derivative is negative, so the function is decreasing here. So 45 to 60. All right. Where does it have a local max or min? So we said on the first page, we said if f prime changes from positive to negative, then f has a local max or min. So our critical numbers are where the derivative is 0. So these 3 points are the critical numbers. So let's kind of summarize what we just said. So positive to negative, we're talking about the derivative here. Positive to negative means we have a max. Negative to positive means we have a minimum. All right, so we are going negative to positive. So the minimum, we have a minimum at 10. This one we're going positive to negative, so that will be a maximum. At 45, and then at 60 we go from negative to positive, so that would be another minimum at 60. All right, so that, I mean, again, if you remember these, which these two are pretty obvious, you know that, I'm sure, by now. If you can remember these, and you can also if you have trouble remembering which is which, positive, negative is max, draw the picture. So positive means you're increasing, negative means you're decreasing. So there you go. You got a max. Negative means you're decreasing, positive means you're increasing. You got a min. So draw a picture if it helps, since we're working with pictures anyway. So another thing you'll have to do is looking at the graph of the derivative, draw the graph, sketch a graph of the function. So, and obviously you can't do it exactly, but you can at least say we are decreasing along this until we get here, and then we're increasing until we get to there, and then we're decreasing to there, and then we're increasing. So you can draw a graph, and it'll tell you where to start. Like we say, start at 0, 0, then decrease because the derivative is negative to there, increase till you get to there, decrease, increase. So get good at that. It is weird at first because the derivative is increasing, so it makes you want to think the function is increasing, but that's not the way it is. The derivative is negative, so the function is decreasing. The derivative is positive, so the function is increasing. So And the more you practice this, the more it'll be quicker to do, or the quicker you will get at it, I guess we should say. All right, so where is it concave up or concave down? So now we're looking where F prime changes direction. So you remember um, where the inflection points is where it changes direction. So if F prime is increasing, we're concave up. If F prime is decreasing, we are concave down. So F prime increasing up, F prime decreasing down. All right, so we are increasing. F prime is increasing from negative infinity up to 30. So that is going to be concave up. And then we're decreasing from 30 to, we'll say 53. And on homework, it is a little, this is pretty, it's hard to tell exactly what that is, but we'll see. I mean, 50 to 60, we'll just say 30% of the way across. So 30 up to 53. And then at 53, we start increasing again. So we're going to be concave up again. So we're going to have a union 53 to infinity. All right. So we're going to do another one of these, same different graph, same questions. So if it is known, so we have the graph of F prime, we're going to identify the same things. And so I'm not going to write the same things. I won't write the notes again, but F prime is positive, F prime is negative. So if it helps, write that every time. And I would suggest probably write it every time until you just know it without having to think about it. So F prime is increasing, or sorry, F is increasing. We need to find where F prime is positive. So F prime is positive from 1 all the way over to 6. And then F prime is positive from 8 to infinity. And another thing, you notice I'm using parentheses on all of these because why? Why? Well, at 1, the derivative is 0. If the derivative is 0, then the graph of the function is flat, it's horizontal. So it's not increasing or decreasing. That's the point where it changes. Then we have decreasing. So where is it negative? So we have negative infinity to, well, maybe 2, or sorry, maybe 0, because it doesn't go past there. So maybe 0, let's say 0. And actually, in which case that would be a bracket. So at 0, well, actually, it's still be parentheses. It's not really doing anything at 0. It stops. So 0 to 1 is decreasing, and then we're going to also have 6 to 8, where the derivative is negative, so the function is decreasing. All right, and then local max or min. So the maximum, we're going from, the derivative goes from positive to negative, and the minimum goes from negative to positive, negative to positive. So, so we have a max where it goes from positive to negative. So that would be at 6. And then we have a minimum where it goes from negative to positive. So that'd be 1 and 8. All right. And then concave up, concave down. So this is where F prime is increasing or decreasing. So this one, we have it increasing from 0 to 2. So that would be concave up from 0 to 2. increasing again from 3 to 5. And increasing again from 7 to infinity, I guess we'll say. All right, so then everywhere else must be concave down. So concave down wherever it is decreasing. So we have 2 to 3 union 5 to 7. And so where are the inflection points? Inflection points would be at wherever it's changing, 2, 3, 7. Or sorry, 5, 2, 3, 5, 7. Just put that on the end of the list. 2, 3, 5, 7. All right. So again, if you practice this a few times, make sure you remember the rules. Understand the relationship with the derivative and the function, and then the derivative with the concavity. And the more you practice it, the better you will get. So make sure you do this several times so that you can not have to think too much about this. All right, so this one is kind of a preview, a little bit of the next part. So here we're not looking at the graph, we're looking at the derivative of the function. So so where is f increasing? So we need to find the critical values. Well, find the critical values. We're going to set this equal to 0. And obviously, hopefully, obviously, you don't need to FOIL all this out, multiply all this out, because then you just have to redo that again to get to here. So this is what you want. So x equals -2, x equals 5, x equals 8. And so what we need to do is we need to plug numbers in. So basically we have intervals negative infinity to -2, and then -2 to 5, and then 5 to 8, and then 8 to infinity. And we need to see on this interval, is the derivative positive or negative? If it's positive, the function is increasing. If it's negative, the function is decreasing. Now, this is very easy, and I'll tell you why. When it's factored like this, if you're plugging in any number for x, which is what we're going to be doing, plug in a number for x, we're going to square it. So that's positive. This factor is always positive because we're squaring it. Same way, this factor is always positive because we're raising it to the 4th. Raise it to an even power, it's going to be positive. So really, we only have to worry about this one. If this is positive, the whole thing is positive. If this one's negative, the whole thing is negative. So that's a shortcut. Now, obviously, you can just plug in x and see what you get, but you don't really need to do that. So if we plug in, so we're just going to pick a number in this interval. So just pick -3, say. So if x equals, well, let's write f prime of -3. So just to make sure we know what we're doing here. F prime of -3. So you plug in -3, -3 minus 5 is -8, -8 to the 5th. Who knows what that is, but it's going to be negative. Doesn't really matter what it is. All we're worried about is if it's positive or negative. All right. Oh, that should be -2. -2 to 5. All right, so then pick a number in this one. Obviously, 0 is the easiest one. F prime is 0, plug in 0. 0 minus 5 is -5. -5 to the 5th is going to be negative again. So we're decreasing from -infinity to 5 at least. So let's see, if we pick a number in that interval, we can pick 6. And you plug in 6. 6 minus 5 is 1. 1 in the 5th is 1. So this one is positive. So then last one, we can pick 9 or 10 or whatever, it doesn't matter. See any number greater than 8. and that one's going to be positive. So 9 minus 5 is 4. 4 to the fifth is going to be positive. So we are increasing on these two. All right, and we'll see more of these on the next part of this sections for 4.3 part 2. All right, so if you have any questions, send me an email and I will answer your questions. All right.